Okay, a bit of a wordy question on probability here. So Dan believes he can guess, well, not get, he knows what Ethan's thinking, i.e., he can read his mind. He carries out an experiment. They sit back to back, i.e., you can't see his facial expressions or anything. We assume it's, he's kind of reading his mind from sitting back to back. And then he rolls an ordinary fair dice that is six-sided, the numbers 1 to 6. Ethan then thinks about the number on the dice, or Dan tries to predict the number. 300 attempts, how many correct predictions would you expect Dan to make if he was just guessing? So if he's just guessing, then he's basically got a 1 in 6 chance of getting it right, because there are 6 numbers on the dice and he's got to guess the correct one. So that, what does that mean? That means in every 6 guesses you'd expect him to get it right once. So in every 3 guesses, well, we're talking about a fraction here, and actually you do a sixth times the number of attempts, and that's going to be 300 divided by 6, that's the same thing, so it's going to be 50. You'd expect him to guess it correctly 50 times. Results of the first 15 attempts are shown. And estimate the probability of getting a matching pair using results of the first 5 attempts. So he's guessed it right the first time, but then it's going to been the 5th time. 1, 2, 3, 4, 5. So if we only look at the first 5 results, well, there have been 5 attempts. He's guessed it right twice, and so the estimate for the probability based on this is actually 2/5. We're using experimental probability here. The number of times he's got it right divided by the total number of attempts. What about in all 15 attempts? Well, this time he's got it right 3 times, and in total there were 15 attempts. So that's your answer. Note, I don't need to simplify that probability. It's absolutely fine as 3 over 15. Use the answers from A and B to comment on Dan's belief that he knows what Ethan is thinking. Well, we expect the probability, so the expected probability of guessing that was equal to 1 over 6. Actual, we call this the relative, sorry, it's actually the experimental probability. The actual experimental probability after 15 guesses, I'll ignore the only 5 guesses, well, that equals 3 over 15, which now I'm going to simplify to 1 over 5. And although he's guessed it a bit more often, I shouldn't say guess, he's got it a bit more often than you'd expect to by guessing, they're very close. 1/5 is approximately equal to 1/6. So, so it seems that Dan cannot. What did the question say at the start? It says cannot know what his brother is thinking, or does not know what his brother is thinking. Okay, bit of a wordy question to end with, but there we go.